Hello, I welcome you all to this another interesting screencast. The problems are resolve each force acting on the support into its x and y components and express each force as a Cartesian vector. The second problem reads determine the magnitude of the resultant force in this direction theta measured counterclockwise from the positive x-axis. Both these problems are coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Benam. So you can solve this problem either by using the parallelogram or any other method. We're going to use the method of components. Right. So let's draw the free body diagram. Let's start with F1. F1 will have a component in this direction like so. Let's go up to there. And another component in this direction like so. Right. Then F2 will have a component in this direction like so. And another component in this direction like so. Alright, and then finally we are going to have another component. F3 will have a component in this direction like so, and another component down in this direction like so. Great. Let's label these quickly. So F3, this is just going to be equal to F3 by the run, which is a 12 divided by 13, and then this one is F3 by the rise, which is a 5 divided by 13. Okay, and then this one will be F1 cos 60. This one will be F1 sine 60. Okay, and this one will be F2 cos 45, and this one will be F2 sine 45. So quickly let's draw a table. So there we go. Okay, there we go. Okay, something like that. Okay, there, and another one. How many more? We have 1, 2, 3, 4, and the last one, which is the resultant. Okay, something like this, and then we close it there. Let's fill it in. So we have F there, we have the X component, we have the Y component, this is F1, this is F2, this is F3, and this is the resultant component, of course. So we said F1 is 800 positive cos 60, and then the Y component is also positive, which is 800 sine 60. F2 we have a negative 600 sine 45, negative X component, and we have a positive 600 cos 45. Then F3 we have a positive 650 by 4 divided by 13, and we have a negative 650 by 5 divided by 13. Alright, and the resultant, let's sum up with my calculator. There we go. So we have 800 cos 60 minus 600 sine 45 plus 650 by 4 divided by 13. So this gives us a 575.74. Alright, so 800 cos 60 minus 600 sine 45 plus 650 by 12 divided by 13. 575.74. Okay. The other one, 800 sine 60 plus 600 cos 45 minus 650 by 5 divided by 13. So this gives us 867.08. Okay, so 800 sine 60 plus 600 cos 45 minus 650 by 5 divided by 13. That's 867.08. Great. So we have FRX equal to 575.74 newtons. We have FRY equal to 867.08 newtons. So we have been asked to resolve each force in Cartesian form. So let's go to the first case, case 1, which is a 2-39. So let's write this. Let's work out this problem. So we have F1, writing this in Cartesian formatting. So we have 800 cos 60. This gives us a 400 I positive plus 800 sine 60. So this one is equal to 692.82J. Okay, and the units for this is newtons. Then we have F2. What do we have? It's a minus 600 sine 45. So this gives us a minus 424.26I plus positive 424.26J. Okay, newtons. And then finally F3. Okay, 424.26. Okay, and 650 by 12 divided by 13. This gives us a 600 I, and then minus a 650 by 5 divided by 13. This gives us a 250J. Okay, newtons. So we have everything. Let's go to the next step, which is now finding the resultant as well as the direction. Alright, so we know that this is of course case 2, 2-14. Alright, let's work out the problem. So we know that the resultant is nothing but equal to, according to the Pythagoras theorem, FRX squared plus FRY squared. Okay, therefore we know that our FRX is just going to be equal to 575.74 Newton, and FRY is equal to 867.08 Newtons. Once we plug in those values there, then we are going to have the following: 575.74 squared plus 867.08 squared, then square root of that, we get a 1040.82 newtons. 1040.82 newtons, right? Okay, so let me draw this before I even calculate the angle. So we have something like this, okay, that is how it looks. And then we have the resultant in that manner, like so. The resultant will be much closer to the bigger vector, so it will be there like so. Okay, so let's label this. This is equal to FRY. This is FRY. This one is FRX, and this one is FR. And then we have the angle, this one there, which is our theta. And we know that this theta is nothing but equal to tan inverse of FRY, remember your soccer tower, or divided by FRX. Therefore, this is just going to be equal to, you know what FRY is? So 867.08 divided by 575.74, a tan inverse of that, we get a 56.42 degrees. Let me check it out again. 867.08 divided by 575.74, tan inverse of that, we have 56.42. Great. Alright, let's outline our final solution. So we have the first set here, which is the set of forces for each one of them expressed in Cartesian vector form. Then we have the resultant there for the three forces, as well as its direction measured counterclockwise from the positive x-axis. I think this is about it, and I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.